So let's resume our discussion for CBSE Physics Electrostatics question answer session. Now this question. Derive the expression for the capacitance of a parallel plate capacitor having area A and the separation between the plate is D. So this area is A. They are having the same area, these two plates, and the separation is D. This is the distance of separation. Okay. Now, first of all, we have to find the capacitance. Next, two charged spherical conductors of radii R1 and R2, when connected by a conducting wire, acquire charge Q1, Q2 respectively. Okay. Find the ratio of their surface charge densities in terms of their radii. So you have two charged sphere. One is R1, other is R2. Now the initial charges are Q1, Q2. Now when they are connected, so charges flows from higher potential to lower potential till their potential is same. At that point of time, you have to find the surface charge densities. Okay. So let's do it. So first, capacitance of a parallel plate capacitor. So what is charge per unit area? Suppose Q is the charge on this plate A. So you know that parallel plate capacitor, one of the plate is connected with the positive terminal of the battery and the other is earthed. Okay. So suppose Q is the charge over the entire plate. So what is the sigma? Sigma means what? Charge per unit area. So sigma is equal to charge divided by total area. This is called the surface charge density. Okay. This. Now area plate, A is area of the plate, D is density, epsilon is the permittivity of the space in between the two plates. Correct. So we know that we have applied Gauss's theorem to find out the intensity at a point due to a charged plate. Okay. Suppose this is the point P. If sigma is the surface charge density, then what is the intensity at this point? As per the Gauss's theorem application, this is the intensity. Okay. This we know already by application of Gauss's theorem. So this is intensity. Now intensity is potential gradient, means potential by distance. Okay. So potential means intensity into distance. So we know the intensity, we know the distance. Correct. Now what is sigma? Sigma is the charge per unit area. Correct. So if you put the value of this is okay. So what is the total charge? Q is equal to sigma into A. Now we have V is equal to sigma. We have V equal to ED, E into D. Correct. Now V is equal to in place of intensity we are putting this sigma by epsilon into D. Okay. So now we know that capacitance of a capacitor is what? Q by V. Okay. So capacitance in place of Q is the total charge sigma A. So you put the value of Q here, and V is sigma D by E. Put it here. So it is capacitance is equal to epsilon A by D. Now higher is the area, higher will be the capacitance. Higher is the distance of separation between the plate, lower will be its capacitance. Correct. So remember, the capacitance of a parallel plate capacitor is epsilon A by D. Now second, now two charge spheres are connected. Okay, as I told you that this is R1, this is R2. Initial charges are Q1 and Q2. Okay, now they are connected. So charges flows from higher to lower potential till their potential becomes same. Okay, so what is potential in a charge sphere? It is charge divided by 4 pi epsilon into the radius. Correct. So for the first plate it is Q1 by R1. For the second charge sphere it is Q2 by R2. So Q1 by Q2 is R1 by R2. Now sigma 1 and sigma 2 we have to find out. So what is sigma 1? Sigma is what? Charge per area. So what is surface area? 4 pi R square. So for the first plate it is Q1 by R1 square sigma. For the second plate, sigma 2 is equal to Q2 by 4 pi epsilon into R2 square. So we have to find out the ratio of sigma 1, sigma 2, put the value of sigma 1, sigma 2 here. Now we have Q1 by Q2, but Q1 by Q2 is R1 by R2. Okay, so we put its value, so we find that the sigma 1 by sigma 2 equal to R2 by R1, correct? So higher is the radius, lower will be its it is inversely proportional to the radius. So sigma 1 by sigma 2 is R2 by R1. Okay, so that's all. Now what is the geometrical shape of equipotential surface due to a single isolated charge? So what is equipotential surface? A surface where, suppose this is a charge Q here at any point. Now if every point has same potential, then the imaginary surface drawn by joining all the points is called equipotential surface. Okay, so all points of a sphere around a single isolated charge have the same distance. So this is possible, all points having same potential if it is at equidistant from the charged point, correct? So this is the charge here at O, so they should be at a distance equal to its radius, correct? So equipotential surface, it is in 3 dimension, it will be a shell sort of thing, correct? So it is having a same potential. So for a single isolated charge, radius is same, therefore sphere is the actual equipotential surface. Okay. Next, and what is the potential? It is Q by R. This question: a capacitor has been charged by a DC source. What are the magnitude of conduction and displacement currents when it is fully charged? Okay, so when capacitor is charged initially, charge flows from the potential of capacitor and capacitance increases. Okay, so initially this charge, suppose this is let us take one example, visualize it. The capacitor has been charged with a DC source. So this is a capacitor and I am connecting with a DC source, correct? Positive, negative. Negative is connected with this. So what will happen? Charge flows till its potential becomes same as the potential of this battery. Now once the potentials are same, no longer charge will flow from the source, correct? Flow of charge will stop. So during charges we will get a current called the conduction current. While it was in charging mode, we will get a current. This current is called conduction current. Therefore, during the charging, voltage changing, because what is this? Capacitance is equal to Q by V. So V is equal to potential is equal to Q by C. So as the potential increases for this capacitor's charge will increase, correct? So during charging, voltage will increase. Change. Now electric field changes during the charges and electric flux in the dielectric of the capacitor also changes. So what is electric flux? From the positive plate to negative plate, the imaginary lines of force will cut. So this electrostatic force per unit area is called electrostatic flux, electric flux. So the electric flux current density, that is the displacement current obtained till it is not fully charged. So once it is fully charged, charge flow will stop, correct? So once the capacitor is fully charged, potential across the plates of the capacitor becomes equal to the potential of the DC source. Hence conduction and displacement current both become zero. So remember, in DC circuit, if we connect with the source, with the DC source, then charge flows for some time but then stops. But in AC circuit, since the voltage continuously varies, so therefore charge flow continues. Okay, so next question. A capacitor of unknown capacitance is connected across a battery of V volt. Okay, charge stored in the capacitor is 360 microcoulomb. Now when the potential across the capacitor is reduced to 120 volt, okay, the charge stored in it becomes 120 microcoulomb. Okay, from 360 microcoulomb the charge stored will become 120 microcoulomb. कब? जब voltage इसका reduced by 120 volt. Okay, so calculate the potential V and the unknown capacitance C. What will be the charge stored in the capacitor if the voltage applied had increased by 120 volt? तो अगर 120 volt बढ़ा देंगे तो चार्ज कितना स्टोर होगा? सो दो पार्ट में क्वेश्चन पूछा गया. तो फर्स्ट केस में लेते हैं कि 360 माइक्रोकूलम चार्ज था, तो चार्ज इज इक्वल टू सी इंटू वी, कैपेसिटेंस इंटू वोल्टेज. तो हमको एक रिलेशन मिल गया 360 इज इक्वल टू सी बी. केस 2 में अभी चार्ज कितना हो गया? 120 माइक्रोकूलम. अच्छा, पोटेंशियल कितना कम हो गया? V माइनस 120 है ना. पोटेंशियल अभी चेंजेस हो गया कितना? बिकम्स 120 ना. दिस इज 120 हो गया, तो 120 इज इक्वल टू 120 माइक्रोकूलम हो गया चार्ज, है ना. एंड वोल्टेज कितना रिड्यूस कर दिया? 120 वोल्ट. रिड्यूस्ड बाई, इट इज़ नॉट द वोल्टेज, इट इज़ रिड्यूस्ड बाई. ओके, सो नाउ पोटेंशियल बिकम्स, इनिशियल पोटेंशियल भी था तो अभी 120 वोल्ट रिड्यूस हो गया. ओके, सो इट इज़ V माइनस, पोटेंशियल इज V माइनस 120 हो गया अभी का. अभी दो इक्वेशन मिल गया मुझे, है ना. CV इज़ 360, तो हम CV के जगह पे वैल्यू पुट कर देंगे, तो यहाँ पे CV का इक्वेशन 1 से पुट कर देंगे तो C का वैल्यू निकल जाएगा. C इज़ द कैपेसिटेंस, करेक्ट. ऑल्सो C का वैल्यू आ गया तो V का वैल्यू निकल जाएगा C का वैल्यू डालने से. ओके, सो वी गेट C एंड V बोथ. सो पोटेंशियल V 180 वोल्ट आ गया एंड कैपेसिटेंस इज 2 माइक्रोफैरेड. सेकेंड क्वेश्चन में पूछा गया कि कैपेसिटर में कितना चार्ज स्टोर होगा अगर वोल्टेज इंक्रीज बाय 120 वोल्ट. तो अभी इसका वोल्टेज कितना है? 180 वोल्ट. 180 वोल्ट से हमको इंक्रीज करना है ना. कितना इंक्रीज करना है? 180 वोल्ट ओरिजिनल वोल्टेज है, इससे 120 बढ़ाना है क्या? ओके, सो V इज इक्वल टू 120, कैपेसिटेंस इज इक्वल टू C. ओके, अच्छा एक मिनट. इस क्वेश्चन में व्हाट विल बी द चार्ज स्टोर इफ द वोल्टेज अप्लाइड हैड इंक्रीज्ड बाय 120 वोल्ट. अभी ये जो 120 वोल्ट वोल्टेज को हमने इंक्रीज किया, इसमें ये नहीं कहा गया कि इनिशियल वोल्टेज जो है ना उससे इंक्रीज किया गया. मान लो कि कैपेसिटेंस का इसका जो वोल्टेज था 0 था, 0 से 120 किया. दैट इज़ व्हाट इज सेड कि वोल्टेज 120 है, कैपेसिटेंस ऑलरेडी हमने, कैपेसिटेंस तो वोल्टेज के ऊपर डिपेंड नहीं करता है, कैपेसिटेंस तो एप्सिलॉन A बाई D के ऊपर डिपेंड करता है ना. कंस्ट्रक्शन उसके ऊपर, एरिया एंड डिस्टेंस एंड परमिटिविटी के ऊपर. कैपेसिटेंस तो हम लोग पहले निकाल लिया, तो चार्ज स्टोर निकालना है, तो QV C भी कर देंगे तो यहाँ पर आ जाएगा. ठीक है, सो दैट्स ऑल फॉर टुडे.